Have you heard about the famous cold foil experiment? In the year 1911, a scientist named Ernest Rutherford came up with a new atomic model which explained the failure of Thomson's plum pudding model. Let's watch about this video to know about the success and failure of Rutherford's atomic model. Our objective is to understand Rutherford's atomic model and its shortcomings. On the basis of the alpha particle scattering experiments performed around 1911, Ernest Rutherford proposed a model of an atom. According to his model, an atom consists of a small central core in which the entire positive charge and almost the entire mass of the atom are concentrated. This core is called the nucleus. The electrons revolve around the nucleus in circular orbits. The necessary centripetal force for the revolution of the electrons is provided by the electrostatic force of attraction between the electrons and the positive charge of the nucleus. In an atom, the number of electrons and positive charges are equal. That is, the total negative charge is equal to the total positive charge of the atom, and the atom as a whole is electrically neutral. Shortcomings of Rutherford's atomic model. Rutherford's model of the atom had some shortcomings. It could not explain the stability of an atom and the origin of the line spectrum. Stability of an atom. If the electrons in an atom revolve in circular orbits, they must undergo acceleration. However, according to the electromagnetic theory, an accelerated electron should continuously emit electromagnetic radiation, and so the electron should continually lose energy. If this happened, the radius of the electron's orbit would decrease continuously and it would spiral into the nucleus. This would make the atom unstable. But this is contrary to the fact that the majority of atoms are stable. The origin of line spectrum. According to Rutherford's model, the revolving electron should emit radiation at all temperatures. A revolving electron keeps losing energy continuously and the frequency of revolution goes on increasing. Hence, the spectrum obtained should be a continuous spectrum, but an experimental observation shows that hydrogen does not emit radiation at room temperature or below. However, on supplying extra energy through heat or electric discharge, radiation is emitted. But the wavelengths are simply sharply defined, giving a characteristic line spectrum and not a continuous one. It soon became apparent that Rutherford's model of the atom required modification. A Danish physicist, Niels Bohr, modified Rutherford's atomic model by adding various proposals from the newly developing quantum hypothesis. We will study Bohr's atomic model in our next section. To summarize, Ernest Rutherford proposed that an atom consists of a small central core in which the entire positive charge and almost the entire mass of the atom are concentrated. This core is called the nucleus. The electrons revolve around the nucleus in circular orbits. The atom as a whole is electrically neutral. Rutherford's model of atom could not explain the stability of an atom and the origin of the line spectrum emitted by the excited atom such as hydrogen. Now you know that Rutherford's model could not explain the stability of an atom. A scientist named Bohr made an attempt to overcome the shortcomings in all of these models. Let's find out about his model in our upcoming videos.